LeetCode question number 951, flip equivalent binary tree. This is medium question. Let's get into it. For binary tree T, we can define a flip operation as follow. Choose any node and swap the left and right childs of tree. A binary tree X is flip equivalent to a binary tree Y. If and only if we can make X equal Y after some number of flip operation. Given the roots of two binary tree, root 1 and root 2, return true if the two trees are flip equivalent or false otherwise. Okay, let's check with the example 1. In this case, root is the did not change, right? So, and then 2, 3, 32, this one is flipped. And then 3 is also flipped, right? So it's going to right side. And then 4, 5 is did not change it. And 7, 8 also flipped, right? So this one is return true. That does make sense. Okay. Next one. Each root is the null, is also true. And then, but only one is the null, is false. Last is this is only one is the null, this false. And then value is different structure. Is 2, so in this case 0, null, 1, and then in this case 0, 1. That is the flip, right? So this is 2. Okay, today I'm gonna use the recursion and then bottom up approach, the checking from bottom first. And then both of them is null is true, but only one of them is null. This is first, same as this one. So the value is the different. That also false. Okay. First, I will make is saying the recursion receive two node 1 and 2. And then if not 1 and not 2, that is null node such as leaf node, I will return 2. And if not 1 or not 2, just one of them is the true, I return false. This is same case of this one, right? Only the root 1 is this is none, that is false. And then next case is if now we have the 1 is the not null, right? So in this case 1 value not same as 2 value, I return false. And then last I will return, make the equation relationship 1 left and then 2 left. Cases did not change it. Here's same 1 right and then 2 right. The order is same 1 left and 2 right. This is the split. And then is same 1 left, 1 right, and 2 left. So in this case, I return true, and then finally I return is same root 1 and root 2. Okay. Some of the people, I have a question. Why you did not use Panasys? Okay, we can also use this one, but if we do not use this one, it's okay because always and the operation is the precede then or. So even there are no Panasys, it also execute and first and then this and first and then now or is next. Okay, looks good. Okay, let's check with time complexity. Time complexity is, okay, let's say this is all of node is n. It touch only 1 by 1, right? So time complexity is linear, and then space complexity we use the recursion, and then recursion stack size is same of the height of tree. The worst case is the tree is screwed on the left side or screwed on the right side. The height is the same of the number of nodes. So we can say it takes linear time with linear space. Thank you.